Obviously, guys, there was no need for us to mark the first question. It's obvious it's allocated 2 marks. So for just stating the Ohm's law in ways, you score full marks. Okay. So now the question says calculate the reading on ammeter 1. Where's ammeter 1? There, it's ammeter 1. What does ammeter read? Ammeter reads the current. Okay, so they don't have to say calculate the current. They just say calculate the reading on ammeter 1. Then you know you've got 2 ammeters. Where is ammeter 1? There's ammeter 1. What does ammeter read? Then it reads current flowing there. Okay, so ladies and gentlemen, very much important. Okay, you should know that the current flow, obviously remember the current flows from positive to negative, so that means the current will go in that way. When it gets there, it splits. Okay, the other current will flow in that direction and the other current will flow in this direction. Okay, let me just indicate in terms of the arrows there to say, let me use these to say you're going to have the current flowing in that direction and another current flowing in that direction. So it splits. Okay, and again, it doesn't necessarily mean that it splits in equal halves. Okay, it depends on the resistance. If you've got too much resistance on this side, then more current will obviously flow through this side because it's less resistance on this side. So the more the resistance, the less the current. The more the resistance, the less the current flowing. The less the current, the less the resistance, the more the current. So because guys, we've got another branch within this parallel connection. Obviously, that current, when it gets there, it's going to split again. Part of the current will flow in that direction, part of the current will flow in that direction until it joins again. Then as soon as it joins, okay, then it means the current flowing there will be the same as the current flowing there. So that means this current, if it's 4, right, then that 4 will split. Maybe one will go that side and then maybe a 3 will flow this side. But we know 16, it's more, obviously this is where maybe 1 would flow and that side more current will flow, and then when it gets to that point it's going to join. So in short, the combination of the current flowing there and there is the same as the current flowing there or flowing there. Obviously that current is going to pass through there and then it joins. As soon as it joins, then it's that current which is the same. It splits, joins, flows, joins, and then obviously there, this is where it split head and then it joins. So guys, you should just visualize. Otherwise, if you're failing to visualize that, just think of water, guys, and regard these wires as the pipes. Okay, so obviously water will flow, and when it gets there, it's a T-junction. You know, you've got a T-junction connecting the pipes. Okay, so obviously some water will flow through that side, the other water will flow through this side. It will just flow until it gets to that point. The same water will flow, and again you've got another T-junction there. Then the other will flow in that direction, the other will flow in that direction, then they will flow, and then from there they join, they continue, and then they get to that point, they join again, then they go into the main pipe. Okay, so I hope you are able to visualize, guys. So now what does the question wants us to calculate? The question wants us to calculate what is it? Let's check. The question says calculate the reading on ammeter A1. Okay, so let's see. Where's Where is the reading? There. Okay. So, ladies and gentlemen, I was just checking this. I just wanted to see that statement. Can you see? They say with switch S closed, the current passing through the 8 ohms resistor is 0.5 amperes. Very much important, guys. You've got the current passing through, let's see, the 8 ohms resistor, which is a 0.5 amperes. Okay, I hope you're able to see there. So guys, that means if we've got the the current flowing through the 8 ohms resistor, we can calculate the V of that 8 ohms resistor. And we know from the initial statement or the initial lesson that I've given, I just indicated that the V of 8 ohms resistor is the same as the V of 16 ohms resistor. Okay, so that means we can be able to calculate the current flowing there and there. And we know the sum or the combination of these two current is the same as the current flowing or passing through ammeter 1. Okay, so guys, in short, what I'm saying, or what I said with that statement, is that V of 8 ohms is equals to V of 16 ohms. I hope you remember this part, guys. Okay, so if this is the case, then let's calculate the V of 8 ohms resistor. V of 8 ohms resistor, it's equals to, obviously we know the formula, V is equals to IR, right? So we've got a formula which says V is equals to IR. It's there on your formula sheet. And again, we've got another formula which says EMF is equals to I into capital letter R plus small letter R. Okay, so we might need to use both of those formulas, but it doesn't really matter for now. I just wanted you to be aware that we've got these two formulas. They are very much important. At some point we might use both of those formulas, or somewhere we might just need to use one. Okay, so sorry, in this case, as you can see, we just need only one formula there, which is IR. Okay, then we know the I of 8 we're just given is 0.5, and what is the R? It's 8. Okay, this is where you can just pull out your calculator, and then from there you can just punch on a calculator. 0.5 times 8, it's actually half of 8, which is 4 volts. Okay, so that means V of 8 is equals to 4 volts, which is the same as V of 16, which is 4 volts. Then how about we calculate the current flowing through the 16 ohms resistor? It's more like water, guys. We want to know the amount of water flowing that side and this side. We know the combination of the water flowing that side and that side is the same amount of water flowing through that ammeter 1, which is the same as the water flowing through that 20 ohms resistor. Okay, so guys, now we can just calculate the V of 16 ohms, right? Obviously the same formula. We know what is it? There's something that we don't know. Obviously, it's not the V that we're calculating, but the current flowing through the 16 ohms resistor. I just noticed after writing this formula. So it helps to start by writing the formula, because you'll be able to see what you have and what you don't have. So we know that the 16, the voltage on the 16 ohms resistor is 4, which is equals to, we want the current flowing through the 16 ohms resistor. Obviously, the resistance is 16. So that means I is equals to 4 divided by 16. Okay, so let me see how much is that. 4 divided by 16, it's quarter, which is 1/4. In decimal, it's 0.25. Remember to write the units. Okay, so that means ammeter 1, okay, the reading on ammeter 1, which is the current on ammeter 1, it's equals to the current flowing through the 16 ohms resistor plus the current flowing through the 0.5 ohms resistor. Okay, and it's actually the total current flowing through that parallel connection, or that branch of the parallel connection. Okay, so that means I've got 0.25 plus what is it, plus 0.5 plus 0.5, which is equals to 2 plus 5 is 7, so it's 0.75 amperes. Okay, so this is how you solve this question. Okay, question 9.2. So that means the current flowing there, it's 0.75 amperes. This is 0.75 amperes. So that means the current flowing there, it's 0.25 amperes. Okay, very much important, guys. And again, we know the V there. Let me just write it there, but you'll remember that we didn't have that V, so that V is equals to 4 volts. Okay, I just wrote it there, but you know it's a V connected across the 16 ohms resistor, which is the same as the V connected across the 8 ohms resistor. Okay, so guys, that part, let's see where we score our marks. So obviously you might be lucky and score a mark from writing the correct formula, which is V is equals to IR. Okay, and the other mark will come from correct substitution, and then from there they just give you a mark for calculating the the current flowing through the 16 ohms resistor, and your last mark will come from the final answer where you indicate the current flowing through that ammeter. So that means this question is allocated 4 marks. Okay, so guys, let's now move to the next question. I assume you fully understand how to solve this question. Okay, so let me just, I think I can wipe all of this, because I assume you've already seen and you understand exactly how to solve that question. So now, guys, let's move to question 9.3. Okay, so let's check what the question says. So the question says,